Hey everyone, and welcome back. Today we're going deep on a topic that quite literally powers some of the most amazing feats of engineering.
Yeah.
I mean, think about it.
Right.
Jet engines, rockets.
Crazy stuff.
We're talking about superalloys and the tools you need to work with them.
You got it.
So to get us started, we've got an expert here.
Hi, everyone. I'm glad to be here.
Ready to dive into the world of superalloys.
Let's do it.
All right. Now, superalloys. These aren't your everyday metals, right?
Oh, no, not at all. These things are...
Like, what makes them so super?
Well, it all comes down to their incredible properties.
Okay, lay it on me.
So think about it.
Yep.
Super strength. They can handle extreme forces without breaking a sweat.
Wow.
Then you've got heat resistance.
Like, how hot are we talking?
We're talking about temperatures that would melt most metals.
No way.
Oh, yeah. And they're also resistant to fatigue.
Fatigue.
Yeah, like they don't get tired under stress. They can withstand repeated cycles of stress and strain without failing.
So they're like the marathon runners of the metal world.
Exactly. And don't forget about oxidation and corrosion resistance.
Oh, right. They're not going to rust away easily either.
Nope. All of this makes them ideal for really demanding applications like
in jet engines.
Exactly. Gas turbines, aerospace components, you name it.
It's kind of mind-blowing that these materials even exist.
I know, right?
But if they're that tough, I imagine it's got to be a real pain to actually work with them.
You're telling me. Machining superalloys, that's a whole other challenge.
What makes it so difficult?
Well, think about it.
Yeah.
All that strength and heat resistance we talked about, it makes it super hard to cut and shape them.
Ah, I see. So your average tools just wouldn't cut it.
Literally. The tools wear down super fast because of the high temperatures generated during the machining process.
I bet that gets expensive.
You have no idea. All that tool wear means more downtime for tool changes, slower production rates, and just higher costs overall.
Sounds like a real headache for manufacturers.
Definitely. But thankfully, companies are constantly innovating and coming up with new solutions.
Like?
Well, there's this company, Iscar.
Iscar.
Yeah. They're a leading manufacturer of cutting tools.
Okay.
And get this, they just launched a new PVD-coated grade specifically designed for turning nickel-based superalloys.
That's it called?
It's called IC1017.
IC1017, huh? All right, break it down for us. What makes this new grade so special?
Okay, so IC1017 builds upon their existing IC806 and IC804 grades.
So it's like an upgrade.
Yeah, like they took what worked well and made it even better.
Cool.
One of the key things is the substrate.
Substrate.
Yeah, basically the foundation of the tool. They've given it a high hardness submicron grain structure.
Submicron. Tiny grains.
Exactly.
What did that do?
It makes the tool much tougher and more resistant to wear and tear at high temperatures.
So the tool itself can handle the heat.
Right. And on top of that, they've added this aluminum titanium nitride PVD coating.
Coating. Like a protective layer.
You got it. This coating helps reduce friction and heat buildup during machining.
Smart. So they're basically giving this tool a super suit of armor.
Yeah. I like that analogy.
So all this techie stuff sounds great, but how does it actually help the machinists out there? What are the real-world benefits?
Oh, it's a game changer. First off, it significantly extends tool life.
Less downtime, less money spent on replacements.
Exactly. And they've seen up to 40% longer tool life in some tests.
Wow, that's impressive.
It also leads to a much smoother surface finish on the parts.
Why is that important?
Well, in industries like aerospace, even the tiniest imperfection can be a big deal.
Right. Safety first.
Precisely. A smoother surface means less chance of cracks or weak points that could compromise the part's integrity.
So this tool is actually making airplanes safer.
Contributing to it, for sure.
That's awesome. Okay, so we've got longer tool life, better surface finish.
Right.
What else?
Oh, and did I mention increased productivity?
Faster machining speed.
You got it.
So this one tool addresses like all the major challenges of working with superalloys.
It pretty much does.
That's incredible.
It's a real testament to the power of innovation.
So we've gone from tiny grains in a tool's structure to a big impact on industries around the world.
Yeah. It's pretty amazing when you think about it.
It really makes you wonder what other innovations are out there, just waiting to be discovered.
Definitely. I mean, as we keep pushing the boundaries of material science, who knows what incredible new materials we'll come up with.
And that's going to require even more innovative tools to work with them.
Exactly. It's a constant cycle of advancement, pushing each other forward.
I, for one, am excited to see what the future holds.
Same here. It's a really exciting time to be in this field.
Well, on that note, that's our deep dive into the world of superalloys.
Hope you all learned something new today.
And who knows, maybe one of you listening will be the one to invent the next groundbreaking machining tool.
The future is wide open.
Thanks for listening, everyone.
See you next time.